Welcome to the One Search for Truth video series, Reconciling Science and Religion in the 21st Century. Before explaining our new theory of the universe, we need a little background on how science has redefined our understanding of existence. It all kicked off nearly 500 years ago when the astronomer and polymath Nicholas Copernicus developed the radical theory that the Earth, rather than being the center of the universe, actually rotated around the sun. A baffling idea to most 16th century Europeans. The first scientific revolution had taken its baby steps. The towering figure of this early scientific revolution was Englishman Isaac Newton. His theory of motion and of gravity presented a model of why objects moved as they did that explained the Earth's orbit around the sun, showing that our planet was governed by the same force of gravity that operated on objects on Earth. The epoch of this first scientific revolution came in the 19th century. By then, science had gone further than overturning the petty superstitions of earlier thinking to undermining the entire model that Christianity, Islam, and Judaism had constructed. With Charles Darwin's theory of natural selection, science now challenged the central notion that man was made in the image of God, seeing us instead as just one in a vast string of life forms with common ancestors, linked by a process of natural selection that required no divine guidance. By the mid-19th century, science had gained a self-confidence bordering on arrogance. The atom was accepted as the smallest, indivisible particle. Time and space were seen to be constants, and scientists were convinced that, like the waves we observe in water or sound waves in air, light and gravitational waves must be transmitted through a medium they named the ether. The universe was accepted as static, neither expanding nor contracting, and in science's quest to understand the external world around us, it was assumed that the observer, us, could be ignored. Above all, Newton's laws of motion gave such accurate predictions that they were accepted as unassailable truths. So widely accepted was this view that in 1878, Max Planck, who would go on to become one of the leading physicists of the 20th century, was advised by his professor at the University of Munich not to bother studying theoretical physics on the grounds that the subject was a highly developed, nearly fully mature science. Then, from its stirrings in the later 19th century, something strange and remarkable started to happen. A new scientific era began to unravel these earlier certainties. Most extraordinarily, in 1905, a humble patent clerk in Zurich, Switzerland, stunned the world with a new and revolutionary theory. Albert Einstein's theory of relativity ripped up the ordered universe of Isaac Newton. It showed that mass and energy are interchangeable, two representations of the same thing, and that rather than being discrete phenomena as previously believed, time and space are inextricably intertwined, one system being warped by mass and energy. With the speed that an object travels through space and the gravitational attraction acting on it, altering the amount of time it experiences while warping the space it travels through. Newton's notion of a universe of constant time and space was shown to be just a very accurate illusion. Then in 1925, belief in a static universe was shattered when, using the most powerful telescope then in existence at Mount Wilson in California, the American astronomer Edwin Hubble discovered not only that there were vast clusters of stars or galaxies beyond our own, but that the universe was expanding, with the furthest galaxies from Earth moving away at the fastest rate. Extrapolating this back in time led the Belgian cosmologist and Catholic priest Georges Lemaitre to propose the Big Bang theory, which suggested that the universe had exploded out from a singularity without time or space, some 14 billion years in the past. The significance of the Big Bang was not lost on religious leaders. In 1951, addressing the Pontifical Academy of Sciences, Pope Pius XII argued that the theory aligned with the notion of God giving rise to creation, as outlined in the book of Genesis. Scientific atheists, on the other hand, found the notion threatening. The famous British astronomer Fred Hoyle, who coined the phrase Big Bang to mock the theory in a 1949 radio interview, felt it aligned too closely with a religious creation narrative. rejecting it in favor of a steady-state theory of an unchanging universe. But a far more sinister attachment to this materialist viewpoint was incubated in the Soviet Union in the 1920s and 30s. The brilliant Russian mathematician Alexander Friedman pored over the equations in the theory of general relativity and noticed that Einstein had inserted an arbitrary constant to ensure a steady-state universe, as was the received wisdom of the time. On reworking the equations, Friedman realized that an expanding universe was a more coherent result. Einstein was at first highly skeptical, but ultimately acknowledged his mistake after famously visiting Hubble at the Mount Wilson Observatory in 1931. The idea that the universe had a discrete beginning proved a sensation amongst Friedman's students, but the Soviet authorities were outraged that anyone would challenge the materialist philosophy that underpinned communist ideology and set about crushing the perceived dissent. Decried as a purveyor of anti-Soviet propaganda, Friedman had his classes and seminars inspected and was followed by the secret police, but died of typhoid before further action could be taken against him. But with a brutality that mirrored, if not surpassed, the Catholic hierarchy's reaction to early scientific advances, far worse was to come, as a number of Friedman's students and acolytes were imprisoned, and some even executed for the crime of doing nothing more than supporting the Big Bang theory. The challenge the Big Bang posed to scientific atheism stemmed from the paradox that if the material universe was all that existed, there could be nothing to bring it about. Materialists have grappled with this problem ever since, many latching onto theories such as the multiverse, which suggest our universe is but one of many hidden from direct observation. But if unseen, unprovable universes could be called upon to explain our existence, why not an unobservable creator? Finally, advances in experimental physics allowed mankind to peer into the world within the atom for the first time. For centuries, scientists had believed the atom to be the smallest, indivisible unit. Now, we knew this to be false. And as physicists peered into this world of tiny particles, what they found shocked and perplexed them. Subatomic particles didn't behave in the predictable ways that seem to govern our familiar world of larger objects. The double-slit experiment, for example, showed that if you fired individual photons, light particles, through a barrier with two slits onto a screen, they created an interference pattern on the screen, just as you would see when ripples from two stones thrown into a pond met and crossed. This interference pattern showed that the photon was acting as a wave, passing through both slits at the same time. But when a detector was placed next to the barrier to see which slit it went through, something strange happened. The interference pattern disappeared, and the photon took the form of a particle, going through one slit or the other. To this day, there is no settled understanding of why such observation or measurement of a particle locks its position into place. Another equally baffling phenomenon scientists uncovered is quantum entanglement. Here, a pair of subatomic particles, such as two photons, can be physically remote from each other, and yet measuring one instantly influences the state of the other if the two were previously entangled, something scientists have achieved in the lab. This suggests a connection that defies the law that nothing can exceed light speed, but physicists are unsure how this occurs. The theory of relativity and the development of quantum mechanics were nothing less than a second scientific revolution, which overturned everything we thought we knew. And they still form the bedrock of our knowledge of the universe to this day. But they are incompatible with each other. The big picture world of relativity suggests a deterministic universe where everything from stars to atoms has a defined place set since the Big Bang, while the small picture provided by quantum mechanics is governed by apparent randomness and uncertainty. Unsurprisingly, since these models became accepted, the obsession of physics has been to find a theory that reconciles the two. The search for the so-called theory of everything. Two leading contenders are string theory and loop quantum gravity. Don't be put off by the names. Both can be described in simple terms. String theory suggests that what we see as subatomic effects are actually manifestations in the four dimensions of spacetime of strings in additional dimensions. Loop quantum gravity suggests that the universe is made up of minuscule interlocking loops, which form the basic building blocks upon which everything is made, and that this provides an alternative explanation for gravity to Einstein's description of it as a distortion of spacetime caused by the presence of mass. Loop quantum gravity proposes that black holes could be portals to other places in space or even other universes. The strange effect discovered in the double slit experiment, that subatomic entities can take the form of particles or waves, but not both at the same time, and that in their wave form they have no settled position, has given rise to some more bizarre theories. The many worlds theory, first proposed by Hugh Everett in 1957, suggests that each possible position in the wave function gives rise to another parallel universe, suggesting that we live in one of an infinite number of universes, each with a slightly different outcome, but all sealed off from one another. Biocentrism suggests that the role of the observer found in the double-slit experiment can only be explained if you see time and space not as external realities, but as constructs of our own minds. It claims that the universe existed as merely a probability until human or animal consciousness caused a fixed reality to be locked into place, suggesting that consciousness is the core of reality rather than the physical world. Supporters of biocentrism often quote the renowned 20th century physicist Erwin Schrödinger. The human mind is the singular of which the plural is unknown. Where has this left physics today? Actually, something quite remarkable has come about. While science is built upon a rigorous methodology of observation, hypothesis, prediction, testing, and validation, or falsification, none of these theories are empirically testable. That's right, neither string theory, loop quantum gravity, many worlds, biocentrism, nor the theory of the multiverse, one version of which suggests that our universe is one of many bubbling up from a cosmic foam, can be considered methodologically scientific. How would you go about testing whether the other dimensions of string theory actually exist? How can you test whether we exist in one of an infinite number of parallel universes? Even the minuscule units that loop quantum gravity suggests the universe is made of are far too small to be detectable with today's technology and may never be. So, remarkably, in attempting to find the theory of everything to unify relativity and quantum mechanics, modern physicists keep finding explanations that lead to other dimensions and universes, the true nature of which science may never be able to uncover, taking them across the boundary from the physical, the universe we observe around us, to the metaphysical, that which lies beyond. The metaphysical was traditionally a place where science was reluctant to tread. Questions considered more in the realm of religion, such as, is there a creator or do we transcend death? So it is highly significant that science has found itself compelled to cross the boundary into the metaphysical with every major modern theory of existence. And there are other known unknowns. Dark matter and dark energy are called dark because they do not absorb, reflect, or emit light or other electromagnetic radiation, but together they comprise 95% of the universe's mass and energy. It is believed that dark matter holds galaxies together, while dark energy has prevented the universe from collapsing in on itself. Some physicists see these as effects from other dimensions or universes leaking into our own, again illustrating how our universe may be shaped by forces from outside the physical boundaries of space-time. The 21st century has been an enormously frustrating time for theoretical physics. Now that science has found that to make sense of our universe, we have to contemplate theories that go beyond its physical boundaries and are therefore not testable, it has reached something of an impasse. If you can't test these theories, you can neither validate nor reject any one of them, leaving modern theoretical physics in a kind of Groundhog Day, an unending, unresolved debating chamber of conflicting, unprovable theories. It is into this context that we present the theory of the singularity of light. and it is to this that we turn in the next episode of One Search for Truth.